Okay, ladies and gentlemen, we are going to introduce our last panel for the day, Green Hydrogen Production Techniques and Technologies. Joining us for this panel, we have Iris ten Have, Head of Science at Extantia Capital, Ignacio Bincaz, Chief Commercial Officer at Advanced Ionics, Iker Marcaide, co-founder at Matteco and Zubi Group, and moderating this panel will be Toby Chan, co-founder and partner at Audacy Ventures. Please welcome them with an applause. Thank you very much for joining us today.
Hello, good afternoon, everyone. I know it's the last one for the day, so please bear with us. Anyway, we'll get going. We all know that in order to meet our net zero 2050 goals, green hydrogen is expected to play a substantial role in that effort. A few years ago, I think a lot of economists and research houses just assumed that we'll get down to $1 per kilogram in the long run. But a few years on, according to the IEA's Global Hydrogen Review in 2023, reads, low-emission hydrogen production can grow massively by 2030, but cost challenges are hampering deployment. And in fact, this recent surge in inflation has actually increased project costs. So I think it's come to the point where we have to seriously examine how to bring that cost down with actual improvements in the technology on top of the benefits of economies of scale. On that note, firstly, I'll hand it over to Iris, who's, as head of science of Extantia, frequently writes these posts that gives a good overview of the sector. So just wondering from your perspective as a VC investor, as well as having an overarching view of the science, like an overview of the current production techniques, what are the bottlenecks, where do you see that additional improvements could be made, and what that means for costs in the long term?
Yeah, thanks, Toby. Appreciate it. Yeah, I guess I'll start close to home. So I think most people think, if you think about green hydrogen, you probably think of electrolysis. And electrolysis is actually the splitting of water into hydrogen and oxygen, which is, I guess, the most popular pathway. I think we might talk about some other pathways later down the lines. The main challenges, in the end with green hydrogen, it will boil down to cost. So we need to find a way to make it cheaper. Well, the underlying cost driver for that cost is typically the energy input needed to split the water into hydrogen and oxygen. So any solution that can solve this is something that we're typically really excited about. To give an example from our current portfolio, we are invested in a company called H2 Pro, and they are working on a system that's maybe a little bit different from, let's say, the PEM, the AEM, and the solid oxide that you've heard before. They're working on a system that's called ETAC, and that stands for electrochemical, thermally activated chemical. So instead of, let's say, doing the production of hydrogen and oxygen at the same time, they actually split that up in two different reaction pathways. So normally if you produce the hydrogen and the oxygen, which is a byproduct of that specific reaction of splitting the water, the production of oxygen already causes about 25% of power loss. So how does H2 Pro solve this issue? They produce the hydrogen electrochemically, but then the oxygen is basically stored on the other side of the reactor, and it's released with thermally, so with waste heat in their case. So they're preventing that, let's say, 25% of power loss, which will in the end translate also in a cost reduction, obviously, if you don't lose that much power, so to say. But yeah, Advanced Ionics, you're also obviously working on a different solution in water electrolysis. So I'm quite curious to hear about that actually as well.
Yes, thanks. So we're working on we call it medium temperature vapor phase electrolysis. So that is 300 degrees Celsius, more or less, operation of steam electrolysis. So we're breaking the water molecule, and like you said, a lot of people we want to bring down CapEx, which is important, but the OpEx, the electricity used to break the water molecule, is key. So we're already achieving under 35 kilowatt hours per kilogram, which is in the range of solid oxide, versus typically most liquid applications are in 50 to 60, right? So
Yeah.
That's the approach. And we do that in a technology that can scale up with nickel and stainless normal materials. So kind of the capex of alkaline and the opex of solid oxide.
Yeah. So basically also not using any, let's say, materials like platinum or iridium that are rather scarce and expensive.
Right, and no membranes, which is like
No membrane. Yeah.
H2 Pro is the
They're
other
also-
technology I
yeah,
know
exactly.
of that's a membrane-less
Exactly.
technology.
Yeah.
Yes.
That's another part of the cost is the membrane, which often obviously has to be replaced.
Cost,
And causes other
reliability,
issues. Exactly.
yes.
So that's also
So
something.
we have
there.
no membrane. Yep. No
Yeah.
ceramics.
Yeah.
What about Iker? Like you're obviously trying to solve the same issue, but more on the component side as well.
Yeah.
Can you please tell us a bit about that?
Yeah, so kind of the story, and we're like 9 months old as a company. So the story is, Zubi is the company I founded and run. It's actually our 10th anniversary, it's on 10 years. And then from there, we create and invest in companies. So we create through our venture builder, and we invest through our various funds from Zubi Capital. And for the venture builder, I was thinking that, you know, besides coming up with ideas, at some point it would be interesting, like figure out how to join forces with research centers and leverage kind of science and deep tech to create new companies. And this is what happened this summer. I crossed paths with a research team in Valencia, and they started me telling about the work they have been doing 10 years in researching like new materials for more efficient hydrogen production. And I said, wow, this should be everywhere in every electrolyzer of the world. So we joined forces, we invested. I actually taken a very active role as CEO in the company in Matteco, and we're already selling around the world in Asia, Europe, and the US, manufacturing. We're getting our gigawatt factory open in a couple of months. Well, we actually, and on Monday, we signed our first major framework contract with electrolyzer manufacturer, which is, we're talking about now hundreds of megawatts for the coming years. And essentially, what the company does is started with the catalyst and kind of innovation on material technology. And it's for AM and alkaline, those two technologies, and non-PGM, so it doesn't have iridium and platinum and so on. And it's essentially the most active version, most catalytic version of kind of what a material can become. And to some clients, we sell the powder. And then to others, we actually create a catalytic layer on substrates that they send us or that we might have ourselves. And this overall, increases current densities at the electrolyzer level, like, 2-3x. So it's a huge savings from a capex perspective. So you can generate, 2-3 times more hydrogen from the same machine, or essentially have something that's 2-3 times smaller, which saves capex. And then also on the opex, we've seen improvements from like 20 to 30% energy consumption. So it gets somewhere in between from like, SOIC, high efficiencies, and traditional alkaline. And then overall, kind of dropping the cost of hydrogen, the LCOH, around 20%. So it's interesting that from something that's like hundreds of millions of investment, right? One of the critical elements that you essentially swap, which is this electrode and the catalysts, have such a great influence on the overall economics, and because essentially they facilitate the chemical reactions from the company. And today we build self-funding the company, and really aspiring to solve kind of the equation for green hydrogen adoption, which is kind of cost, and how to bridge that cost from non-polluting and polluting options, right, for hydrogen.
Yeah, thanks for that. Do you see any issues like as you scale up the production? I think previously we talked about like the challenges in sort of scaling up these technologies, even though it's proven the efficiency in like small scale. If you can talk a little bit about that as well, that'll be.
Yeah, it's interesting, and I think this goes back to like say as a component supplier or strategic. Is interesting because we see, so we have our test benches and our capabilities to do at a certain scale, but then when it increases, it goes to a client site. So right now, so we're selling over the world, and these clients are testing and scaling that up, right? They start with something small, which is cheaper to test, and then they go into, several square meters. But it's interesting because everyone is doing the same work. And they actually share with us, we cannot share with other clients. So it seems like everyone's reinventing the wheel, right? And there's kind of really no standards for like even something as simple as accelerated stress tests. There isn't like a common testing standard. And of course, that also brings that every system is different, right? And we like to say that, we love our material, but we love not our component to work, but the system to improve thanks to our component, right? So what we're really interested is the system, which is the client product, to work really well. But of course there's other variables outside our product, is actually how our product interacts with many other things, like membranes, like levels of molarity, temperature, pressure, all those different things. So it starts kind of being more, complex field from that perspective. And I think, as say, deep techs or clean techs is interesting because for you to mainstream your solution, you, of course, have to have manufacturing capability and give confidence to your clients that you're going to be able to scale up, right? And actually, there is a word we've heard from our clients, like if you're a startup and if you're just lab stage, I don't want to talk to you. Like, I don't care how good your stuff is. I just don't want to talk to you. When you're over that, come and talk to us, which is interesting, right? In most of the industries, typically you start with something small, you sell, you grow, you raise funding. Here, you actually need like a footprint, capabilities to do at a certain scale, to even be able to get into like big frame contracts.
As part of the consideration you've chosen to self-fund like the first part of this journey.
Yeah, because otherwise it would just, otherwise the equation will be, we just ride on public financing, we go slow. And, for me, fight against climate change is a fight, it's an urgency. So in our case, we want to go very quickly. And we're proud that as a deep tech, essentially we're over the world, 9 months into it, we already have our product all around the world.
Do you find it challenging because you're making like a specific component, like let's say the catalyst, the electrodes, what you're focusing on, to get, let's say, these manufacturing partners to agree and test your materials? And if so, have you considered, let's say, building a first-of-a-kind plant yourself to make sure you've proven it and doing that with public funding, for example?
So it's interesting. So discussion. So we've received some public funding, and we started kind of moving that. But I like to think that, you have to build companies with private income, and income from your revenues more, and that's like the extra, right? That's the icing of the cake. But the thing is, like, every electrolyzer is different, right?
Yes.
Everyone has their own twist. We would say, Ignacio, we've done this fantastic, 1 megawatt test in alkaline. He would say, I don't really care. Send me the material, I'll figure out on how it works on our setup.
Right.
You know what I mean?
Yeah.
It's interesting. So everyone's trying to create their own angle.
Yeah, and in that sense, you're like agnostic to what kind of exact electrolyzer it is, because you're only working on the catalyst, basically,
We essentially,
or on the electrodes.
We want to be the Intel inside.
Yeah.
Like, we want to be in every catalyst, electrolyzer, AEM and alkaline electrolyzer. But of course, then you'll have, the Dells and the HPs and all that stuff competing against themselves with different use cases, different price points, different performance, or whatever. So it's the same technology that can be used in very different ways at customers.
Yeah. So it's really more like a platform, actually, in that sense. You can use it for many different things. Yeah.
And that you can customize really well, depends on the specific uses. So it could be the same catalyst, but applied in a very different way, depending the use case. And I think when we think about creating a company like startup, scale-up, is complex by itself. How you actually ingrain flexibility, customization, testing variables is actually what probably makes clean tech even more fun, right?
Yeah.
What about Ignacio? What about
Interesting.
your scale?
And,
Yeah, because you've already raised the Series A, I believe, last year.
yeah, so we raised tranche 1. We're now raising tranche 2,
Yeah.
getting close to the finish line on that in the next month or so.
Yeah.
It takes time, it takes money. We need a lot of people, and we started building hardware in 2021. We went from like a 5 square centimeter button cell to 100 square centimeters, and now we're moving towards 800 square centimeters. We started our first stack of the 100 a few weeks ago. So, being an entirely different technology, a new approach, there's a lot of testing that needs to be done. But anyway, that stack is a project with the Repsol Foundation. So
Yeah.
Now that we're in Spain is very, very relevant. I mean, we're continuing to scale up. We'll do the first stack on the 800 later in the coming months.
And did you decide to do all the engineering in-house at that point in time, or did you choose like an engineering partner to make it quicker and do the third party?
So we're working with an engineering partner for the balance of plant.
Yeah.
We're designing it, the basics, and we're patenting it for a plug and play. And it's interesting, you're looking at customizing, right? And we're looking at making a really standard plug and play module that would work for refining, for ammonia, for green steel, for glass, for any industry. But the architecture of the stack, the cells themselves, there's a lot of IP that's trade secret, so we have to keep that in-house.
Yeah, so you don't want to give away too much, let's say.
Right.
Yeah.
So, all right, so from Extantia's point of view, apart from H2 Pro, do you see been probing other areas of investment along the green hydrogen space, and what part of the value chain, or do you favor other production techniques? Or we talked about electrolysis. What about like some of the other potential pathways of green hydrogen, so to speak?
Yeah, good question. I mean, we do see quite a few hydrogen companies out there, like hydrogen production companies out there. I'm always happy to sort of, to chat and to see what the innovation is that they're working on, and to see how that's working out. But there's also obviously other methods to make green hydrogen. I think the other route that we briefly discussed outside here is more like a biomass pathway. So for example, from wastewater, which often has organic components, you can actually liberate, let's say, the hydrogen and the carbon from that wastewater by changing chemically transforming the organic components into something else. However, there you will always be limited by feedstock. So that's sort of the feedstock availability, because you're using waste materials or biomass, will always be a limitation, and therefore that alone can never, let's say, serve the green hydrogen market by itself. But it's an interesting technology for specific use cases. That's really, really interesting as well. But that being said, we definitely need a lot of electrolyzer capacity to be developed in the coming years if we want.
I think like the technology readiness of some of these other methodologies. There's a long list, gasification of biomass, biophotolysis, like all these. Like probably limited by like feedstock.
I think in that sense it depends on the geography. If you're in an area where green electricity is really cheap, you probably should work with electrolysis because you have cheap electricity. But if you're in an area where sustainable biomass is available but not much green electricity, probably makes more sense to do the biomass route rather than the electrolysis route, so to say.
Definitely.
So depends. We're going to need both. So
I think. Of course, we're discussing technologies, but the overall aim is to, there was a lot of discussion about cost. I saw on Ignacio's company's website, there's a long-term goal, actually not so long-term goal, that's a more new-term goal, that there is a cost target of achieving that holy grail,
the dollar,
yeah,
the famous dollar per kilo. So yes, we have a couple of scenarios in our techno-economics with 2 and 4 cents per kilowatt hour, for example, and we let people play with the spreadsheet with whatever numbers they want. But those two numbers take you to right above or right below $1 per kilogram, considering capex and opex.
But I think what maybe also worth touching upon this topic a little bit, because when we were standing outside, the three of us were actually discussing how misleading this $1 per kilogram is, because there's always underlying assumptions in this $1 per kilogram, right? So maybe in that sense, it's maybe more fair to split the cost up in OPEX and CAPEX, and then, talk, for example, from a kilowatt per kilo or kilowatt hour per kilogram perspective, rather than saying dollars per kilogram.
So then, in the OPEX, take the 35 kilowatt hours per kilogram, add a couple more kilowatt hours for system losses, let's say. Multiply that by your favorite power
electricity cost. So what is your favorite electricity cost? Zero.
Actually, the higher makes us.
What's your favorite realistic electricity cost?
We don't pick a number. We're actually quite agnostic. Okay, actually, higher numbers make us look better with the lower OPEX compared to other technologies. But like you said, right, the lower the price, the better for everybody, because then electrolysis makes more sense.
Yeah, that being said, realistically speaking, renewable electricity is probably not going to be freely available anytime soon. You know, it's, as one of you said, it's not like the internet in that sense.
Right, yes.
Yeah.
The marginal cost. I think it kind of leads to discussions like, you know, there are not going to be projects everywhere.
Yeah.
I mean, there's that geo, angle clearly to like the cost of production, the economics, and especially if we think about centralized production, not decentralized. And as you're saying, there's like, I mean, in fact, I mean, we, as a startup, always say that you got to choose your battles very carefully, and order matters, and how you tackle, right? Yeah. So in some sense, for us, we've like started with two technologies, AM alkaline. We started with hydrogen, but we see more as new material innovation for decarbonizing the world. And the fact is that there is just pathways for hydrogen very different, and for decarbonization as well. So in some sense, I think it's like how you leverage the terms in the market to, get an entry ticket into a party that you can leverage and reinvent yourself afterwards, right? And then that will create kind of an area of solutions that might be interesting, for different use cases in different locations. Yeah. That at the end overall kind of contribute to decarbonization.
Yeah, so depending on the resources in different places, there will be hubs that will be good at making hydrogen through electrolysis with low power costs. Some other areas, like you were saying, biomass.
To have sustainable biomass and not so much green electricity. So
photocatalysis.
Yeah.
There's plenty, and of course, that different TRLs.
Yeah.
So in some sense, kind of the opportunity that we've seen is where if we create a platform that can integrate, we kind of have the, IP and technology and product roadmap. We have, the go-to market and the access, and then we have the industrialization capacities. Maybe we don't have to generate everything in-house, right? How can you actually take stuff that is on low TRLs and bring them through your platform to maturity and leverage your industrial footprint and go to market? Yeah. And with that, kind of create a lot of synergies across. Right?
Because you said photocatalysis, do you think your technology would also fit in there? Because I've so far not seen that many, let's say, close to commercial applications for hydrogen production with photocatalysis.
Well, I think photocatalysis is this, first is taking, the light and then catalyzing a reaction. So you actually, typically the antenna is, I think it's titanium based. So it's like actually combining things makes a lot of sense. So our technology can be used even for, like you mentioned, biomass. It can be used, or like direct electrochemical reaction into e-fuels. So it can be used in many different things. The question is like, where's the market in each of those, and what's the order is actually very relevant. That's why, for some sense, we've been like self-funding for the first use case, and we're thinking, okay, the order you should actually create a company is you have industrial, you can manufacture products, you can sell products, you have clients, and then you raise funding, right? That's the that's the natural order world. It's true that we've set up some companies in the past. I mean, my first venture, we raised 300 million, was a 4 billion exit. First company I founded 15 years ago. And the other was a bit different. Raised 20 million. I think we're doing like, a few thousand euros in revenues, and raised, 10 million. Yeah. So yeah, I'm trying to kind of follow the right order of the playbook of entrepreneurship in this one. But, and I think in some sense, if we think about clean tech, if we can get to the point of like self-fund for the initial use case, and then actually raise funding is more around expansion opportunities, licensing, M&A, expansion of production capacity, etc. So more like the expansion stage, because then it actually takes away a lot of the risk, which is inherent to clean tech and deep tech, which is, do you have a first customer that is paying you to make the company self-sustainable, right? If you solve that, and then you're in the next step, then you're in a good point, right? To raise funding, make it predictable, argue that you're hitting metrics, whatever. If you're getting investors too early while you're like maneuvering, and then you might get into a tricky situation.
This is like wrapping up the session. Final question. Where do you see the green hydrogen market like developing over the next, say, like 5 years? Like, well, of course, you guys are pushing, spearheading sort of the improvement in techniques. Do you have any sort of words of wisdom for the audience?
So for me, first it will be decarbonizing existing users of hydrogen, right? I'm not seeing any big remote plants making hydrogen, putting it into a pipeline that doesn't yet exist, but rather existing ammonia plants or new ammonia plants, refineries, eventually green steel. That's the processes that are using that molecule today, emitting CO2, will start replacing that with green hydrogen. And for us, it's perfect because then the process heat from that unit brings us the heat we need to get the efficiency.
Yeah. I mean, we didn't even speak about all the 50 shades of hydrogen today, basically.
Yeah.
But most of the hydrogen currently on the market is gray, right? And there's maybe a little bit of blue hydrogen coming up where you're like, cracking the methane or natural gas and you're capturing the carbon, so blue. And then green is currently like almost non-existent part of the actual market. And I hope in the coming 5 years that's slowly going to ramp up, let's say. Let's put it that way.
Okay, let's all have our fingers crossed, and thank you for the panelists. Thank you.
Thank you.